we doing, everybody? This is That Our Nerd, back at it again with another algebra tutorial. This lesson today covers adding and subtracting fractions, which, as we all know, is a beautiful, beautiful thing, and quite possibly maybe the most beautiful work of art of all time. Without further ado, let's get into these fractions here. So the general formula here is if we were to have A divided by B plus C divided by B, then the addition for this would be A plus C divided by B. So what this is basically saying is we add across our numerators, and our denominator we leave the same. We leave it the constant, whatever it was. For this, B cannot be equal to 0. For subtraction, it's really similar. A divided by C minus C divided by B. What noob put C over here? Golly. What a noob. A divided by B, right? And we'll have A minus C divided by B. And again, B cannot be equal to 0 because anything divided by 0 is undefined and not real. Okay? It's like well, my fake friend, you know? Little Billy F. Donovan. Okay? He wasn't real. Alright. So do not divide by 0. That's not good. So let's do our thing here. So if we had 6/7 plus 3/7, what we would do is we'd add across our numerators. We'd have 6 plus 3, and we divide by our denominator, which we leave the same. We don't change. We don't add these two denominators here. It's not 7 plus 7, right? This is not 14, it's 7. So the denominator stays the same. So 6 plus 3 is 9 divided by 7. It's cool beans. But what if our denominators are not the same, right? What if we had 3/7 plus 4/5? Well, we can't do this as it's set up right now. We need our denominator to be the same. So you can find the least common multiple, or you could just multiply these two numbers together. If you need to figure out how to do the least common multiple, I have a link here. Press that button and you can go watch how to do the least common multiple. But for this one, the least common multiple is the same as just multiplying these two bottom numbers together. And so what we're going to need is 35 and 35. Right, and we talked about equivalent fractions on the last video. So how would we get this 7 to be a 35 on the bottom? Well, we'd multiply it by 5, right? So if we times that by 5, that bottom one's going to become 35. But if we multiply the bottom by 5, we also need to multiply the top by 5. If we don't, it's not an equivalent fraction, and we're changing the numbers, and it's no bueno. All right, it's no good. So 3 times 5 is 15. And that would be our numerator for the first one. Now we need to make this 5 down here. We need to make this into a 35 as well. And so we can do that by multiplying it by 7. And again, if we multiply the bottom by 7, we need to multiply our numerator by 7 as well. 4 times 7 is 28. And now that we have common denominators, we can just add across our numerators and then leave our denominator the same. So this can be 15 plus 28 divided by 35. And we'll see how good my mathematical skills are here. 15 plus 28 is 43. 43 divided by 35. And I'm not sure we can simplify that at all. Off the top of my head, it appears not to. So that would be our final answer for that addition. Same process goes for if we had subtraction. So let's say we had Huckleberry Finn's 9/8 minus 5/12. Well, we can find the least common multiple, right? So let's do our little factor tree here. 8 is going to be 2 times 4, 2's prime. 4 is going to be 2 times 2, and 2 and 2 are prime. So 8 is 2 times 2 times 2. 12 is going to be 6 times 2. 2 is prime. That's going to be 2 and 3. And 3 is prime. Again, if you're not sure how to do these least common multiples and factor trees, you can go watch that video that I had earlier. That goes into more detail on how to do these factor trees here. But this prime factorization is going to be 2 times 2 times 3. And so for our least common multiple, 2 appears the most here, right? 3 times as opposed to 2. So we'll take 2 times 2 times 2. And 3 appears the most times here, where it appears once. And so we'll do times 3. 2 times 2 times 2 is 8. 8 times 3 is 24. And this one was relatively simple, right? You could see that probably pretty quick just by looking at these numbers. But this is good practice to see the process if you did have more complex numbers that you needed to find the least common multiple for. Okay, so our least common multiple is 24. We know we're going to need to find 24 for both our denominators and make these into equivalent fractions for that. So 8 times what gives us 24? 8 times 3. And again, for an equivalent fraction, what we do on the bottom, we also have to do the top. So 9 times 3 is going to be 27. For 12, what times 12 gives us 24? Well, that's going to be 2, right? And again, we have to do that by the top and the bottom. So 5 times 2 is 10. So now we have common denominators. We just subtract across our numerators. So 27 minus 10, 17, divided by 24. 17 is a prime number, so we're not going to be able to factor that down anymore or simplify it. So 17 24ths would be our answer for that problem right there. I hope this video was of help to you. If it was, make sure to drop an addition onto that like button, and make sure to subscribe if you'd like to see more algebra tutorials or lessons similar to this one. And have just a phantasmo day. Thank you for your time.